In our previous video, we spoke about what motion is. We defined motion as a change in position of a body with change in time. And we also looked at some examples and also some various types of motion. So in today's video, we are going to take one, which is the most common, the linear motion. We're going to take linear motion and look at it very well. We are going to look at some basic things also associated with linear motion and other type of motion. So when we say linear, it's even in the word, taking the word linear motion. So when we say linear, what comes to mind? We can see line in the word linear. We can see line in the word linear, meaning what? Linear motion. So a motion which is described by a straight line or a straight path. So in our previous video, we made mention that the path defines the type of motion that the body takes. So when the body is moving in a straight line, then that body is undergoing a type of motion known as linear motion. So linear motion is a type of motion in which the body moves in a straight line. Now, when dealing with linear motion and other types of motion, we have some basic terms that would be seen in all this kind of motion. So with these basic things, we'll look at distance, displacement, speed, velocity and acceleration. We also have deceleration. So now these terms are seen in almost all the various type of motion, but depending on the type of motion that it is dealing with, you have a name added to it associated with that type of motion. So assuming it was in a straight line, we would have said linear displacement. Assuming it was in an arc, which would eventually form a circle, we would have said an angular displacement because it would be describing an angle as it's moving. Would have said angular displacement. So in the same way, we have linear speed and linear velocity. Angular speed, angular velocity. Then we also have linear acceleration and angular acceleration. Now, we've already spoken or we've already said that linear motion is a type of motion described on a straight line or on a straight path. So that's linear motion. Now, with these things, we'll be looking at displacement and distance for today. These two things are actually very similar. They have few things in common but are also distinct. Meaning there are some features that make them distinct. So now with distance. So distance is just like the separation between 2 points. So the total separation or the total path taken by a body between 2 points. So it can be the initial and the final point. So with distance, we can have point A here and point B here. And let's say the body takes a path and come here. So the total path that will be taken by the body from its initial point, that's point A, to the point B. The total path that it will take to point B is distance. So the separation between these 2 points, the total separation between these 2 points is distance. So you can see that it's not in a straight line. It's not necessarily in a straight line. It's just that it has to cover this whole place before coming to point B. The body moving from point A to point B. So this total path taken by the body is distance, and it is measured in meters, or it's measured in meters. Also, since we don't have any specified direction, we are just looking at the total path taken by it. We can say, or we would affirm that distance will be a scalar quantity. Distance is a scalar quantity. So you can say measured in meters, that will be one, and also a scalar quantity. So that's what we'll say about distance. Now looking at displacement, that we are taking, since we are dealing with linear motion, we are going to deal with linear displacement. So with linear displacement, it is the total separation between 2 points in a specified direction. So now we will see that with this one, we're having a specified direction, that's one, and it is a straight line, or it's moving in a straight line. So still taking points A and B, point A and B. So the shortest line possible, the shortest path possible, and it is in a straight line. So with this, with linear displacement is a separation between 2 points with a specified direction. Now we'll see that yes, it is in a specified direction. So we can say one, it is a vector quantity. So let me write linear displacement here. So the right place to write. Sorry for that. So we are writing, so this is linear displacement. So one is a vector. You see that because it's moving in a specified direction, we can say it's a vector quantity. It's a vector quantity. And it's also measured in meters because it is it's just length, but in a specified direction. So it's also measured in meters. That would be a similarity between distance and linear displacement. So we have measured in meters. There are some other key things that we must also note when dealing with this too. When distance, when let's say the body covers a straight line, it can turn into linear displacement since it is taken in a straight line and surely be in a specified direction. Also, we know that with observation, you could see that the total path that this body will take, total path that will be measured in meters, will be greater than the shortest one taken by this body. One is in a straight line and is the shortest path. So we could see that distance is always greater or equal to displacement. So assuming the body takes a straight path from its initial point to its final point, but not in a specified direction necessarily, that total path that will be taken could be equal to the linear displacement taken by that same body, because the body will be taking its shortest path possible from its initial point to its final point. Now, you could see that yes, distance is always greater than the linear displacement or equal to the linear displacement if it's taken in a straight line, but not necessarily a specified direction. Now that we know some basic logics between distance and linear displacement, we could now go to the other themes associated with motion in our next video. Thank you for watching this video, and I hope to see you in our subsequent videos.